likely not be there in your board exam problems. Okay, it usually never is. So AMGM inequality is mostly for JE or ISI level problems. And told you, right, whenever you find a problem on inequalities, always first try the AMGM inequality. Okay, that is going to be your base. After that, you will also find more inequalities in the chapter of vectors, if I remember. In vectors, you will get an inequality also. It should be a modified version of the triangle inequality. Okay, so try that inequality. If you feel that it is a geometric problem involving triangles and sort, then start, instead of the AMG inequality, start with the triangle inequality. A plus B greater than C, B plus C greater than A, and C plus A greater than B. All right. This is not a definitive list. There will be some problems which will be solvable with other inequalities, but this is just a way to start. Okay. Sometimes you see a problem and you don't know how to start. Those problems are the worst problems of all. Okay. Because if you can start, you know where you are lacking or where you are getting stuck, or you will solve the problem. Okay. But if you cannot start only, then it's a problem. So AMGM inequality, that is why we did last day, relation between AMGM and HM, and we did 2 problems just to warm up. All right. So these were chapter end problems, not that difficult. We will continue now. I'll give you some new problems and let us do those. Okay, fine. Take 5 problems first. These problems are not that difficult, so you should be getting answers. Okay, treat them as subjective problems. You don't need to tell me all of the answers at once. If you have completed one, you can call out the answers. Okay. Have you finished number one? Number one should not be that difficult, right? Divisible by 2 or 5. Yes? Anyone? Number one? Yeah. What is the logic behind number one? It says 2 or 5. That means divisible by 2, divisible by 5, and then what? Come on, these are like barely more difficult than NCRT problems.
Is it 3050, the first one?
Yes, 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 yes. How did you do it?
First, I added all the numbers between 1 to 100 divisible by 2. Then I added the ones divisible by 5. Then I subtracted the one that are divisible by 10. The LCM of 5 and 2. I made that
Yes,
common.
yes, yes, yes. So, what formula did you use for adding?
Uh, n by 2 into 2a plus n minus 1d for 3.
Uh, could you not use that last one? I mean, n by 2 into a plus l, because
Okay, okay, okay. Oh, sorry, I missed that. I
that would
extra
be
work.
easier, no?
Yeah.
Fine, okay, correct. Uh, let us do it. So, basically, what you are doing is you are taking number one, right? So, you are taking divisible by 2, you are adding divisible by 5. Now, this is double counting, right? Because the ones that are divisible by 2 and 5 are counted in both. So, you are subtracting this. So, minus divisible by 2 and 5. So, this is basically 10. All right. Now, can any one of you tell me how does this relate to set theory? This
It's
particular,
asking for A union B. So we have to NA plus NB minus A intersection B.
very good. Okay. So, start looking for these patterns. All right. I'm not talking about this particular problem, but in general, you will notice these patterns throughout your mathematics course. Okay. Once you begin to see these hidden patterns, then you might be ready for some unexpected problem that might link these two branches. Okay. I will never be able to give you an example of that problem because that's what unexpected means, right? So you might get a problem in your ISI exams that relates these two somehow, because you can see that theorem in here, you can taste it, right? You can smell it. That thing is here somewhere. Okay. You will find that in probability as well, right? P of A union B is equal to PA plus PB minus P of A intersection B. And then when you learn about mutually exclusive and all those events, then P intersection A intersection B becomes 0. So P of A union B becomes P of A plus P of B, right? All of those things, it'll lead to Bayes theorem and so on. Okay. So just look out for these. Anyway, divisible by 2. So 1 to 100, how many numbers are divisible by 2? You can just add from 2 to 100, right? So how many numbers will that be? 50. And that will be just n by 2 into a plus l, right? So it will be 50 by 2 into a plus l. So that will be, or you can take 2 outside, right? You can do 2 plus 100. That's also okay. You can just take 2 outside. So n by 2 into a plus l, and then you can go with 5. So for 5 we will have how many? 20. So 20 by 2 into 5 plus, what is the last one? The last one is again, I think, 100 again, right? And then you will subtract. There will be 10 here. So that will be 10 plus 100. So these will get subtracted. Did I do this correctly? Yep, done correctly. If you use the 2a plus n minus d form, you will get it a bit different. So I'm writing both of them. So you will get it as 50 by 2 into 2a. So 2 into 2 plus n minus 1, which is n is 50. So 49 into 2. All right, this is what you will get. But notice that this is in total 2 into 2, 4, and 98, 102. This is also 102. Now you decide either which one is easy, this one or that one. I cannot tell you which one is easier, because whichever one hits here first, that is what we will go with. Okay, you don't need to wait around in the exam hall for the perfect solution to strike you. Okay, no need to wait around. Time is of the essence in exam hall. Okay, so either this, or you can go with, I mean, this entire set will become now 20 by 2 into, so that will be 2 into 5 plus 19 into 5, right? Again, you will observe that the sum is the same. Okay, let me move this a bit. So that will become 10 plus 95, 105, which is the same here. And you can just write 10 by 2 into 2a, I mean 2 into 10 plus 9 into 10. Again, the sum will be 110, right? Both of these are correct, and you solve this, you will end up with, the numbers will be 2550 plus 1050. So 2550 plus 1050 minus 550, I think. Yeah, that will give you 3050. Yes, any doubts in question 1? Anyone? So either go with this formula, or you can go with that formula. All right, then go for number 2.
Is the next one 4? X equals
4.
to 4.
4 is fine. Yes, I don't see answers from anyone else. What, are you all confused or not doing? Confusion cannot be the case, right? Because these are basic problems. If you're confused here, then you need to study more. The solution to the equation. Okay, others, take 2 more minutes to try this, and those who have completed 2, move on to number 3. Yes. Number two. Anyone else? Log 7 base log 5, right? So you'll have to take the anti-log twice. I don't know how this got classified as sequences and series, but okay, it's fine. So basically you get this, you can shift the 7, right? So if you shift the 7, what would you get? You would get log 5 base root over of x plus 5 plus root x is equal to 7 to the power 0, which means 1, right? So you'll also have root over of x plus 5 plus root x is equal to 5 to the power 1, 5, right? Now
X is
here,
equal to 4.
yes, yes, correct. So it was, it is quite bad that you did not have options here, right? But here you can check with smaller numbers. Okay, by that I mean just look into 5. 5 is an integer, right? So before you start solving this, always check the integers that can give 5. So 5 can be 2 plus 3, 5 can be 4 plus 1, right? So if x equal to 1, then what do you have? You can either get 2 plus 3 or 4 plus 1, right? Or you can get 5 plus 0. So if you take it as 0, that will not work. 4 plus 1, that means x has to be 1, right? And x plus 5 has to be 4. Yeah, so that means you cannot get an x that will give you 16 here. That is not possible, because if this was 11, then this would be 11, right? Otherwise you cannot get 16. So that means it has to be 2 and 3. Now if x is 3, you will get root over 8 plus root 3. Not happening. If x is 2, what will you get? If x is 2, then this has to be, sorry, if this outputs 2, you will have to input 4 here. So if you input 4, you will get root over 4, 2, and you will get 3. So 3 plus 2 equal to 5. So x equal to 4 works. All right. Not always would you have to solve the entire thing. Sometimes for these problems, you can just think about integers. Just try 2-3 combos. If you cannot figure it out, solving it is always an option, right? You always have the option to write it down and write the equation down and solve it. But do check, because sometimes these things are quite easy. All right. If this is 1, then x has to be 1. If this is 2, then x has to be 4. If this is 3, then x has to be 9, right? If this is 9, then you will get 3 here, but you will get root 14 here. So that means it is the only whole square that is near to 5 is 5 plus 4, which will give you 9. The next one is 5 plus 11, and this one does not have a square root. Okay, so that is how you can intuitively get the answer. But otherwise you will just square it. You will get x plus, you will basically get 2x plus 5 plus 2 into root over of x square plus 5x is equal to 25, right? Or you will get this is going to that side, so you will get 20. Everything will cancel by 2, so you will get x minus 20 is equal to minus of x square plus 5x under square root, of course, right? So once you square that, you will get x minus 20 whole square is equal to x square plus 5x. Now you just have to solve it, right? So what will you get? You will get x square minus 40x plus 400 is equal to x square plus 5x. So this goes away, and you get,
So 10, not 20.
yeah, 10. Fine. So that will make this 20, and it will make this 100. So 20 and 100. So that should give you 25x equal to 100. So this means 25x is equal to 100, which means x equal to 4. All right. Now, if you were able to solve the equation from the guesswork, we will call it guesswork, right? That we did here, you would save the time of all these 6 steps. Okay. And in exam, time is currency. All right. So I hope you understand where I went with this. This was a simple problem, but you could have done it much more simpler since nothing was given here, right? So I'll just write the answers here slowly. So this was 3050. This is 4. The next one, yes? Anyone? Number 3. The sum of the first n terms of the series 1 into 1 square plus 2 into 2 square. Separate the terms. That is a hint. You just have to separate them. So you see every odd term is 135, and every even term is, if you take 2 common, it's the sum of all even terms, right? So this is 1 square plus, you can separate it out in 2 pieces. So this is basically you will get when n is odd, and then you, Okay, does this say odd terms? Okay, the sum of even terms is given. You just have to figure out the sum of odd terms, right? So the sum of first n terms of the series dash is n into n plus 1 whole square by 2, where n is even. When n is odd, the sum is. So when n is odd, just look into what the series is. So when n is odd, the first, look at the first three terms. It contains two odd terms and one even term, right? So what does that mean? This means that when you have n terms, you are going to have how many odd terms and how many even terms? Just try to do a sort of induction in your head and figure it out. So if there are three total terms, you have the division as 2 and 1. What happens if there are 5 total terms? You have the division as 3 and 2, right? For 7, it will be 4 and 3. So what will be it for n? It is n plus 1 by 2 and the remaining one, right? Think n minus n plus 1
Is
by
it
2.
n square plus n cube by 2?
N square plus n cube by 2. Yes, n square plus n cube by 2. Okay. So how many odd terms are you having? You have n plus 1 by 2 odd terms, right? So when n is odd, you have n plus 1 by 2 odd terms and twice into I mean n minus 1 by 2 even terms, right? Let us not write this like this. Terms from 1 square plus 3 square plus dot dot dot, and terms from 2 into 2 square plus 2 into 4 square and so on, right? So we can take the individual sums. So what is 1 square plus 3 square plus 5 square plus dot dot dot? How will you sum these up? This is basically sigma of 2m plus 1 whole square, right? And you know what this is? Sigma of n square is?
N into n plus 1 into 2n plus 1 divided by 6.
So just instead of n, put 2m plus 1. So it will be 2m plus 1 into n plus 1. So 2m plus 2 into 2n plus n into n plus 1 into 2n plus 1. So that will be 4m plus 2, matlab 4m plus 3, right? By 6. That will be the sum where m belongs to z plus, right? So that will be the sum. So once you have this, we can do the other one as well. So we have this 2 into 2 square. I can take 2 common, right? So if I take 2 common, then I'll get 2 square plus 4 square plus dot dot dot, right? Now for this, it is just 4. Should I take 4 or should I take 2
So
into
that's
2?
written 2 into 2 square.
Yes. I can take 2. No. See, these terms are all multiplied by 2 anyway, right? These terms
I
are all
thought those were
multiplied.
decimal points.
No. Product. So 2 is multiplied by them anyway. And even without the 2, we'll also get another 2 common from here, right? So let us not keep that 2 together. Okay. If I do not keep that 2 together, then I'll have one more outside. So that means it will be the original 2 that was there, I can just write this as 2 into 2 square also. That also I can take out. And then this will be 1 square plus 2 square plus 3 square plus dot dot dot. Right? This works.
Which is the even number sequence.
Which is the normal sequence, right? Oh, are you talking about
Oh,
this
no,
this one or this total one?
no, my bad.
Okay, fine. So this was 2 into 2 square, 2 into 4 square, 2 into 6 square. Right? So for 2 into 2 square, not only do I have the 2 that was in the problem, but also from this 2 square, I can take 2 and 2 common. So I am left with 1. From this 4, I can take 2 into 2 common. So from each 4, I have 2 common. So this will be 2 and this will be 2. So this is 1 plus. So this is basically 8 into. This will be for m. What will this be?
N into n plus 1 into 2n plus 1 divided by 6.
Yes, the normal one. So m into m plus 1 into 2m plus 1 by 6. All right. If we add them, we should get the final answer. All right. So this will cancel out, right? One of them will cancel out. I'll get 4 here and I'll get 3 here. Okay. So what can I take common? I can take 2m plus 1 and m plus 1 also common, I think. Because yes, I can take 2m plus 1 and m plus 1 common, right? Because this is another 2 here. So I can take 2m plus 1 into m plus 1 common. And also, okay, let us keep the by 6, not cancel it, because it will help in getting stuck
Sir,
together.
we can cancel out the 2 in the above one also, na? 2m plus 2. There we can take 2 common and
Okay, okay, yeah, yes, fine, fine. So let us keep it 4 here and let us make both of these 3's and make this one m plus 1. Okay, by 3 and let this one be 3. So this is by 3 common. All right. So once we take that common, what will I get? I'll get, check 2m plus 1. I'll get 4m plus 3. And if I take 2m plus 1, m plus 1 by 3, I'll get 4m. Okay. So this will give me yes, everything is fine. And so simplify it, you will get 2m plus 1 into m plus 1 into 8m plus 3 divided by 3. Now you can replace 2m plus 1 equal to n, and that should give you your answer. Check if that happens. There is a bit of algebraic manipulation here. Check, check. So if you replace n equal to 2m plus 1, see if that gives you your answer.
Sir, I have a question.
Ask.
Where did we get this formula from?
Which one?
This m into m plus 1 into 2m plus 1.
By 6.
Basic.
Okay,
Yeah,
so
I see.
you can prove it by mathematical induction. You know what mathematical induction is, right?
I've not done it.
Okay, so for mathematical induction, you assume that the formula is correct. Okay, so assume that n sum of 1 square plus 2 square plus 3 square plus 4 square dot 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 is equal to n into 2n plus n into n plus 1 into 2n plus 1 by 6. Okay, assume that this formula is correct for n. Then try to prove that the formula is correct for n plus 1. Okay, and you know that formula is true for n equal to 1. All right, because if n equal to 1, then what do you get? You get 1 into m plus 1, which is 2 into 2n plus 1, which is 3 divided by 6. So 1 into 2 into 3 divided by 6, 6 by 6, 1. The first term was 1 square. So for 1, the formula is correct. Okay, if the formula is correct for 1, and when you assume that the formula is true for n, if you can prove, it's a bit of algebra, you should be able to prove that n plus 1 is true. That means for every present term, the next term is true. And we know that 1 is true. So if 1 is true, then 2 is true. If 2 is true, then 3 is true. 3 is true, then 4 is true. And it becomes true for everything. Okay, that is known as mathematical induction. All right, it's a very logical proof. It can be done in two ways. You can either start from 1 and show that it holds up to infinity, or you can start from infinity, show that it holds for infinity minus 1, and show that it holds for 0. Okay, so that means this one true, that means this one was true, that means this one was true, that means this one was true, and if 0 was true, that means it all reached a logical conclusion. Okay, so one is forward induction and there is backward induction. We do not teach backward induction in current syllabus because it's a bit more logical and it is used for a class of problems that are not included in our scope of syllabus. So we always go with forward induction. Okay, clear? That is how you can prove this formula.
Yeah, but I don't
Fine.
understand how we got the formula in the first place into this.
Oh, so we are adding the sum of squares, right? So if
Yeah,
sum of n square is n into n plus 1 into 2n plus 1, then the sum of 2m plus 1 will just be 2m plus 1 replaced in n. So that is why I got 2m plus 1 into 2m plus 1 into 2 into 2m plus 1 plus 1. So this 2m plus 1 plus 1 gives you 2m plus 2, which the 2 cancel out with, and this is 4m plus 2 plus 1, 4m plus 3.
yeah, but then how do we know that n square is equal to that?
That is the formula just I told you, right?
Okay.
So sum of n square, this is equal to n into n plus 1 into 2n plus 1 by 6. Sigma of n, this is equal to n into n plus 1 by 2. Okay, sigma of n cube, this is equal to n into n plus 1 by 2 whole square. All right, you can
Okay.
prove these. These are provable, but if you want, we can do them next day. Okay, I'll just have to look into it. These are given in standard NCERT books. All right, since people just assume it to be true, we just do the induction proof. Okay, if you want, we can do the induction proof. That is not an issue. But
No, sir, I understand.
okay, just try to look into it. See if you can find them in the NCERT book. If not, I am writing a reminder here. We can look into the induction proofs next day. All right, that is fine. Someone solved this one, right? It was Tiasha, I think. Tiasha, have you solved this? The second.
Actually, I didn't do it the way you did.
How did you
They
do it?
gave us the even. They gave us the sum of numbers if n is even. So
Yes.
I took that, and if n is even, then if I take n as odd, if n is odd, then n minus 1 would be even. I put that in the formula they give. Then I
Oh,
added n square to it.
why did you add n square to it? Because
Because there are n numbers given, and I have n is odd and n minus 1 is even. So I put n minus 1 in the formula, which is even, which gives the sum till the even numbers. Then,
oh yeah,
according to pattern, so I add another n
fine,
squares.
fine,
Then I'm
fine.
getting the
That
answer n cube plus n square by 2.
that works. You can take n square common from there as well. Okay,
Okay.
and you will get the formula as n square into n plus 1 by 2. Okay, but try this one. So this formula, I think we need to try it once again. So
Actually, I tried this one. My answer is not matching, so I was
not
about to
matching, right?
ask you.
Mm-hmm. All right, let us try it this way. First, let us write out your solution. That is quite an elegant one. Well done. So I hope you all understood what was the best possible solution here. So let us write that down. So even terms, sum of even terms is given to be n into n plus 1 whole square by 2. Okay. So uh, if n is odd, this implies n minus 1 is even, right? So sigma of n terms is just equal to sigma of n minus 1 terms plus nth term, right? So sigma of n minus 1 terms means this will be finishing up to n minus 1, right? So that means this will be n minus 1 into n squared by 2, right? And the nth term will be, what is the nth term? This is 1, first term, 2, 3, third term is 3 square, fifth term is 5 square, so nth term will be n square. Okay, so n square. Just add this, you will get n cube minus n square plus 2n square by 2, that is equal to n square common n plus 1 by 2. This is the best solution. All right, I think this sum was probably intended to be done in this way. All right, but now let us try the alternate solution. Okay, a bit expanded. So in the alternate solution, let us take it from before n. Let m equal to 2m plus 1 because this is odd. All right. So if m equal to 2m plus 1, then what are you getting? You are getting the series as 1 square plus 2 into 2 square plus 3 square plus dot 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 plus, let us write the last few sums, that is 2 into 2m whole square plus 2m plus 1 whole square, right? So this is basically sigma of 2m plus 1 whole square plus 4 into 1
Sir,
square,
eight
just
into
just a minute, 1 square plus 2 square plus dot 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 plus 2m whole square, no, plus m square. Does this make sense? This makes sense because m is already even, right? So what will be the first term? This first term will be 4 into 2, 8, but this first term is not 8.
Hard line का बुझने पड़ेगा.
This one, right? This should be 8.
I told that only.
Yeah. But if this is 8, then what is the second term? Fourth term. The fourth term is 2 into 4 square, right? So 32. And here it is also 4 into 8, 32. Yeah, fine. Okay. This works. 8 is okay. So if this is 8, then we should be able to continue in the same way. If we continue in the same way, we get here. Let us not cancel anything right now. Let us keep everything what it is. So this will be equal to m square. Okay. Why not replace the value of m anyway? So this will become, no, keep m. So this will become 2m plus 1 into 2 of m plus 2 plus twice 4m plus 2, 4m plus 3 by 6. Oops. Yeah. By 6. And this would give you 8 into m into m plus 1 into m 2m plus 1 by 6. just let us check this formula once. Check this formula for m equal to 1. See if our calculations are correct. So if m equal to 1, n should be equal to 3, right? If n equal to 3, that means the three terms here will be 1 plus 2 into 4, 8 plus 3 square 9. So that should be 18. That means for m equal to 1, the sum should be 18, right? If that happens, then our formula is correct. So write it down. So here you will get m equal to 1, you will get 3 into 4 into 7 by 6 plus 8 into, I put m equal to 1, right? So 1 into 2 into 3 by 6. So this cancels 2. 14 plus 8. No, we get 22 here.
22.
So that means the formula is not correct. So that means the only way this will be correct is if we put n equal to 4 here, right? Think. Because if this is 4, then this will be 4. If that is 4, then you will get 14 plus 4, 18. And our formula becomes correct. Okay?
But then, sir, the sequence is then not correct. Right?
Sir, we are actually then doing, we are taking 2 square plus, it is 2 into 2 square. So we are just taking it as 1 square plus 2 square plus 3 square and separating out the square terms, the even square terms. That we are doing.
Yes, that we are doing, right? So what are we missing here? Can any one of you look here and tell me what is missing? Because what I get is if I have 2 into 2m square, this is 2 into 4m square, right? And this 8 should be outside. But that does not work. We just check by substituting in the formula. So what is missing here?
Actually, that sigma 2m plus 1 whole square, we are taking the sum of the first n odd terms, but that formula is not like that one. Like the sum of first n terms is that one that you have written.
I did not understand.
Sir, you are taking the sum to from 1 square plus 2 square plus till 2m plus 1.
Hmm.
Consecutive terms square you are taking, not to the odd terms
No,
square.
that does not matter. That does not matter. That does not matter because 2m plus 1 whole square, I can just replace it in the formula. This part is absolutely correct. You saw, right? Because 14 plus 8 was giving us 22. So this part is correct. We should have it as 14 plus 4 equal to 18. So this part is the only one that was showing the error. All right. So let us not waste time on it. I'll give you the explanation next day. I have to look a bit
So
more into it.
actually, I am actually want to say that you are taking that 1 square plus like the first term you are taking what like 1 square plus 2 square plus 3 square like that.
No, this is basically these terms are separating out. The odd terms are getting collected here. Okay. And the even
So
terms are
then
getting
that
collected. Then
that formula, how are you matching with that the sum of the first n consecutive terms? Like I cannot
yeah.
understand.
You have 1 plus 2 plus dot dot dot. Sorry, 1 square plus 2 square plus n squared is equal to n into n plus 1 into 2n plus 1 by 3. This is an identity, right? Identity means n equal to anything will, sorry. Identity means n equal to anything should satisfy this formula. Anything means n belongs to z. Anything should work. So even if I put n equal to 4n plus 99, that should also work here. This is just an example. Okay. So you can put it on the left hand side as well as in the right hand side. Just like in a plus b whole square, you can put a and b anything. The formula should stand. This works similar. Okay. You can take a smaller example and check. Check the normal sum. Check 1 plus 2 plus dot 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 n. This is equal to n into n plus 1 by 2, right? So if this works, if I take n equal to 2m plus 1, what does this sum become? This sum becomes 1 plus 2 plus dot 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 plus 2m plus 1. This should be equal to 2m plus 1 into 2m plus 2 by 2. which means m plus 1 into 2m plus 1. Now this is my formula. Now I will verify it. See if this works. Take m equal to, take m equal to 2. So that means my sum will be 1 plus 2 plus m2 means till 5, like. So I should get 15 here. Put m equal to 2, I'll get 3 into 5, 15. Works? So in any identity, you can replace the thing that you are having the identity with by any other term and it will work. That is the definition of identity. Now you are clear. How can I replace this 2m plus 1, this 2m plus 1 in the n into n plus 1 formula? Is this absolutely clear to everyone? 6. Clear?
Yes, sir.
Okay. So what is not clear is that why we are taking 4 here instead of 8. So I think that is
Sir,
on.
I was saying that if you are taking 8, then basically you're doing 2 into 2 square plus 4 into 4 square.
No.
Yeah, and the remaining terms we have is 1 square plus 3 square plus 5 square. When you are
Really?
substituting
Okay. Let us check that one. So you are saying 2 into 2 square plus what is the
plus
next term? 2 into 4 square, right? 2 into 4 square plus 2 into 6 square. Let us take these three terms. So if I take 2 common, I'll get 2 square plus 4 square plus 6 square. So if I take, what is this? This is 2 into 2 plus 4 into 4 plus 6 into 6. Now, if I take 2 outside from every one of them, so I'll get 2 and what is this? This is 2 into 2. So I can take 4 in 1 into 1 and I can take, if I take 4 outside, I'll get again 1 into 1. Yeah, right. So I cannot take 8, right? I'll have to take 2 common from here. Because if I take 2 common from here, then I'll get 1 into 2. That also does not work. If I take 4 outside, I'll get 1 into 1. If I take 4 outside, I'll get 2 into 2. No, it works. If I take 4 outside, I'll get 3 into 3. Okay, so this 4 can be brought outside once again. So then I should get 8 into 1 into 1 plus 2 into 2 plus 3 into 3. That should work, right? That is why I was getting 8 here. But we are supposed to get 4. I think that happens
Yes.
because of this that we did last time, right? That n minus 1 by 2 terms. That 2 I think somehow cancels out this 8. Okay, that is what my intuition says. But I will verify it next time and get back to you. Okay, so let us keep this sum till here. I will recheck the logic once again, because if I apply this formula, it will absolutely work, right? So I can take here 2m plus 1 and m plus 1 outside, right? So if I take, just let us check. I take 2m plus 1 and m plus 1. So m plus 1 into 2m plus 1 by 6 outside. What remains in the brackets? In brackets, it remains 2 into 4m plus 3. And here I have 4m. See if that works. 2 into 4m plus 3 and 4n, right? Because this m plus 1 here was multiplied by 2. So I just kept it. So, and this becomes m plus 1 into 2m plus 1 into, this is 8m plus 6, this is 12m, 8 plus 6, right? So what does this become? This becomes 6 common. That will be 2m plus 1. Yeah. So it will become just a 2m plus 1 whole square. 2m plus 1 whole square. And if I write it as 2m plus 2, I'll get by 2. So now as n equal to 2m plus 1, so I can write this as n square into 2m plus 2 is 2m plus 1 plus 1. So n plus 1 by 2. Okay, so this is how this sum should go. Now this 4 and 8 logic, I will try to find a bit more easier explanation. Maybe I'll write out a few terms and check. But this is the traditional way in which you are supposed to do this. Okay? By you are supposed to do this, I do not mean that this is meant to be done in this way. That is obviously the best way that we have done already. Okay? According to this problem. But if this even was not given, then we would have done it in this way. All right? I will check this factor of 4 here, why it works like this. But apart from that, is the solution clear?
Yes, sir.
Everybody? If we just ignore and assume that the coefficient is 4 instead of 8,